Preparing for a generative AI interview? You're in the right place. Generative AI is changing the world, from large language models to agents, RAG, diffusion models, and beyond. Companies like Google, Microsoft, OpenAI, and Apple are hiring experts who understand not just the basics, but the advanced techniques, risks, and future of AI. In this video, I'll walk you through 150 unique and interview-ready questions with world-class answers. Each one is designed to help you explain concepts clearly, confidently, and concisely, just like in a real interview. By the end, you won't just be answering questions, you'll be standing out as the expert in the room. So let's dive into it. What is generative AI? Generative AI is a class of models designed not just to analyze or classify data, but to create new content text, images, audio, or code. These models learn the probability distribution of data and then sample from it to produce realistic outputs. Unlike copying, they generalize and generate novel combinations. Large language models like GPT can write essays or summarize reports, while diffusion models create high-fidelity images. The power of generative AI is bringing creativity, automation, and personalization into domains once limited to humans, transforming industries from healthcare to entertainment. How is generative AI different from discriminative AI? The difference is in what the models learn. Discriminative AI models learn boundaries. They predict labels given an input, essentially learning PY given X. Think of a spam filter. It labels email as spam or not. Generative AI models instead learn the data distribution P of X or P of X comma Y, which lets them generate new examples. For example, instead of only classifying a cat image, a generative model can create a new realistic cat. Discriminative models serve detection and scoring, while generative models focus on creativity, simulation, and augmentation. Many companies combine both for synergy. Why did generative AI take off recently? Generative AI has existed for years but surged recently because of three factors. First, scale. Massive GPUs and distributed training enabled billion-parameter models. Second, algorithmic breakthroughs. Transformers, attention, and diffusion made models far more stable and powerful. Fine-tuning techniques like RLHF and LORA gave us usable, aligned outputs. Third, internet-scale datasets provided the richness needed for broad generalization. Together, these pushed generative AI from research to real-world utility. That's why we now see tools like ChatGPT, Midjourney, and GitHub Copilot being used daily by businesses and consumers. What are the main families of generative models? There are four main families of generative models. Transformers dominate text and code generation engines behind ChatGPT and Copilot. Diffusion models excel at image, video, and audio via iterative denoising powering stable diffusion, and DALL-E GANs pioneered photorealistic images and remain useful for fast synthesis, though harder to train. VAEs capture latent spaces for controlled sampling and interpolation. Increasingly, we see hybrids diffusion guided by transformers. The choice depends on data type, fidelity, controllability, and performance constraints. Explain the transformer's role in generative AI. Transformers revolutionize generative AI by solving the bottleneck of long-range dependency modeling. RNNs and LSTMs struggled with memory and parallelization. Transformers, with self-attention, weigh the importance of each token relative to others, capturing deep context. This matters because predicting the next word or code line often depends on earlier tokens. Transformers scale effectively. You can train them across billions of parameters, which is why GPT-4 or Gemini exist. In generation, auto-regressive decoding creates coherent, contextually rich outputs. Instruction tuning and RLHF ensure alignment with human goals. What is the difference between pre-training and fine-tuning? Pre-training is when we train a model on broad, general-purpose data, like books, code, or the internet, to learn language and reasoning patterns. It's essentially giving the model world knowledge. Fine-tuning, on the other hand, is adapting that pre-trained model to a specific task or style, often with smaller curated datasets. For example, instruction fine-tuning teaches a model to follow commands. RLHF aligns it with human preferences, and domain-specific fine-tuning adapts it for legal, medical, or enterprise use cases. Pre-training gives capacity, fine-tuning gives direction, and together they make a foundation model useful in production. How do diffusion models generate images? Diffusion models work by learning to reverse a noise process. During training, images are gradually corrupted with noise until they're nearly random. The model then learns step by step how to denoise them back to a clean sample. At inference, we start from pure noise and iteratively denoise toward an image. When conditioned on prompts, cross-attention links, text embeddings to image features, guiding the generation. The strength of diffusion lies in its stability, high fidelity, and controllability by adjusting guidance scales, schedulers, or providing partial images. You can influence style, composition, or even edit existing visuals. When would you pick GANs over diffusion or vice versa? GANs and diffusion each have trade-offs. GANs produce sharper images with fewer steps and lower latency, which is great for real-time or edge applications. But they're notoriously hard to train and prone to issues like mode collapse. Diffusion models, while slower due to many denoising steps, are far more stable and controllable, and currently lead benchmarks in image and video quality. In practice, if speed is mission critical, like generating avatars on device, a GAN or distilled diffusion may be ideal. For creative industries, research, or high-fidelity art, diffusion tends to be the preferred approach. What is a latent space, and why does it matter? Latent space is a compressed, abstract representation of data where similar inputs cluster close together. In VAEs, GANs, or multimodal models, it captures the semantic essence of the input. This matters because it allows smooth interpolation between concepts, controllable edits, and attribute manipulation. For instance, in an image model, moving in one latent direction might change lighting, while another might alter facial expressions. In text-image models, latent alignment lets prompts meaningfully guide outputs. Latent space is essentially the creative playground where models reason and where we can intervene to steer outputs. How do you evaluate generative models? Evaluating generative models is challenging because quality is subjective. For text, we look at perplexity, BLEU or ROUGE, but increasingly use preference models and human ratings to judge coherence, usefulness, and truthfulness. For images, metrics like FID, inception score, or CLIP score capture realism and alignment. Beyond automatic scores, human evaluation remains essential, asking if outputs are accurate, safe, and aligned to task goals. In production, we also track latency, cost per token or image, bias and toxicity levels, and business-specific success metrics. A balanced mix of quantitative metrics and qualitative feedback gives the most reliable evaluation. What are hallucinations and how do you mitigate them? Hallucinations are outputs where the model generates confident but false or fabricated information. They happen because models predict plausible patterns, not absolute truth. Mitigation strategies include retrieval-augmented generation to ground answers in real data, schema-constrained decoding to enforce structure, and requiring citations with confidence calibration. Some systems add post-processing checks or use secondary models to verify outputs. In high-stakes domains like healthcare or law, strict guardrails and refusal policies are essential. The goal is not to eliminate hallucinations entirely, but to reduce their frequency, flag uncertainty, and ensure outputs remain trustworthy. What is retrieval-augmented generation (RAG) and why use it? RAG combines retrieval systems with generative models. Instead of relying only on what the model learned during pre-training, it fetches relevant documents at query time and injects them into the model's context. This provides up-to-date, domain-specific knowledge, reduces hallucinations, and allows answers to be grounded with citations. Technically, it involves chunking source data, embedding it into vectors, storing in a database, and then retrieving relevant pieces for fusion in the prompt. Companies use RAG to keep assistants current, compliant, and trustworthy without the cost of retraining giant models. How do you control a generative model's style and behavior? There are multiple levers. At the prompt level, you can use system prompts to set tone, role, or rules, and few-shot examples to demonstrate desired format. Decoding parameters like temperature or top P influence creativity versus precision. At the architecture level, you can fine-tune with adapters or LoRa for brand voice. For structured use cases, schema-enforced outputs and tool calls provide reliability. In image generation, prompt weighting, negative prompts, and guidance scales adjust style. The key is combining these controls with governance filters to balance creativity with safety and consistency. What are the main risks of deploying generative AI in production? The biggest risks include hallucinations, biased outputs, data privacy leaks, intellectual property infringement, and vulnerability to prompt injection attacks. Operationally, cost overruns and latency bottlenecks are also concerns. To mitigate these, organizations deploy safety filters, watermarking, and retrieval grounding, and sanitize inputs to prevent injection. Governance frameworks ensure compliance with regulations like GDPR or HIPAA. From an engineering perspective, monitoring drift, usage anomalies, and output quality is crucial. Ultimately, successful deployment is not just about the model, but about the guardrails, observability, and policies around it. How do you reduce cost and latency at scale? Scaling generative AI requires efficiency. Companies often use cascaded models, routing easy queries to smaller, cheaper models and reserving large models for complex cases. Prompt compression and context filtering reduce token usage. Techniques like batching, caching, and streaming improve throughput and user experience. On the training side, quantization and LoRa reduce compute requirements for fine-tuning. Teams also track token budgets and cost per query, running A/B tests to balance quality and spend. The key is to treat efficiency as part of product design, not an afterthought. What is RLHF and why is it important? Reinforcement learning with human feedback, RLHF, is a technique for aligning large models with human preferences. After pre-training, a model is fine-tuned on examples, then trained with reinforcement learning using a reward model built from human rankings. This ensures the model doesn't just generate plausible text, but text people find helpful, safe, and aligned. For example, RLHF is what makes ChatGPT conversational and polite, rather than raw and unfiltered. It bridges the gap between statistical learning and human expectations, making AI more usable in real-world settings. What are LoRa and parameter-efficient fine-tuning? Low-rank adaptation LoRa is a technique for fine-tuning large models without updating all parameters. Instead, it introduces small trainable matrices within layers, keeping the base model frozen. This reduces compute and storage costs drastically while still adapting models to new domains. Parameter-efficient fine-tuning methods like adapters, prefix tuning, or LoRa are popular because they allow organizations to deploy multiple versions of a model for different use cases without retraining from scratch. This is especially important as foundation models grow in size and cost. What is prompt injection and how do you defend against it? Prompt injection is when malicious users craft inputs that override instructions or cause harmful behavior. For example, tricking an AI assistant into leaking secrets or ignoring safety rules. It's like SEQL injection, but for natural language. Defenses include input sanitization, allow lists, restricting sensitive functions, isolating secrets from prompts, and output verification. Some systems use layered classifiers to flag unsafe or adversarial prompts. Because attacks evolve quickly, organizations need continuous red teaming and monitoring to stay ahead. Treating prompts as part of the attack surface is critical in production deployments. How do you combine generative AI with external tools or APIs? Generative AI becomes far more powerful when integrated with external tools. Models can generate reasoning steps, then call APIs for real-time data, calculations, or actions. For example, a travel assistant might generate an itinerary, but use an API call to fetch live flight prices. Architecturally, this involves function calling or tool use frameworks, where outputs are structured as JSON schemas or commands. This hybrid approach combines creativity with accuracy, letting the model reason in natural language, but delegate tasks requiring precision or updated knowledge to specialized systems. What is multimodality in generative AI, and why is it important? Multimodality means a model can handle and generate across multiple data types: text, images, audio, video, or even sensor data. For example, GPT-4 with vision can interpret images as input, while models like Gemini or Claude are being extended to audio and video reasoning. This is important because human communication is inherently multimodal. We don't just use words, we use visuals, tone, and gestures. For businesses, multimodal AI unlocks use cases like analyzing medical scans with text notes, creating marketing campaigns with copy and visuals together, or building voice assistants that truly understand context. What is an AI agent in the context of generative AI? An AI agent is more than just a model. It's a system that can perceive, reason, and act toward goals. In the generative AI context, an agent uses a model like GPT not just to generate text, but to interact with tools, APIs, or environments. For example, a sales agent might query a knowledge base, draft an email, and log activity in a CRM. Unlike static models, agents operate in loops. They observe, decide, and execute. This makes them powerful for autonomous workflows, customer support, and research tasks. How do agents differ from standard generative AI models? Generative AI models are powerful predictors. They generate content based on input prompts, but they are passive until prompted. Agents, by contrast, are active. They decide when and how to act, can chain reasoning steps, and call external tools. Think of a model as the brain, while an agent is the whole organism. It senses, plans, and acts. That distinction is what enables applications like autonomous research assistants, personal co-pilots, or even robotic systems where decision-making loops are required. What is a reasoning loop in AI agents? A reasoning loop is the cycle an agent follows. It observes the current state, reasons about possible actions, takes an action, and then evaluates the outcome before repeating the cycle. This loop allows agents to break down complex tasks into smaller steps and adapt dynamically. For example, a research agent might search a database, summarize results, decide the next query, and iterate until it has enough information. Without this iterative loop, most generative models would just produce a single response and stop. What are multi-agent systems and where are they useful? Multi-agent systems are setups where multiple agents collaborate or compete to solve a problem. Each agent might have different roles. One might retrieve data, another validate facts, and a third generate polished text. In simulations, agents can represent users, businesses, or markets interacting with each other. They're useful for brainstorming, testing negotiation strategies, modeling supply chains, or running what-if business scenarios. Essentially, multi-agent setups let you scale beyond one model's perspective to collective intelligence. What is memory in AI agents, and why is it important? Memory allows agents to retain context across interactions. Without memory, every query is stateless, like talking to someone with amnesia. With memory, an agent can recall prior steps, user preferences, or previous failures. Memory can be short-term, keeping recent conversation history, episodic, recalling specific events, or long-term, embedding knowledge into a vector store. For example, a personal AI tutor can remember your past mistakes and adapt lessons accordingly. Memory makes agents more human-like, consistent, and efficient. What are the challenges in building AI agents? The biggest challenges are reliability, grounding, and safety. Generative models are probabilistic. They may hallucinate or take suboptimal steps. Without proper guardrails, agents may loop infinitely or misuse tools. Another challenge is orchestration, deciding when to call the model, when to use tools, and how to pass context efficiently without blowing up latency or costs. Security is also critical. Agents can be vulnerable to prompt injection if exposed to untrusted inputs. Finally, evaluation is harder since success depends on task completion, not just a single answer. How do you evaluate AI agents? Evaluating agents goes beyond model metrics. You need to measure task success rate, number of steps to completion, error handling, and user satisfaction. For example, if an agent is a coding assistant, does it generate working solutions consistently? And how often does it require human correction? Simulation-based testing is often used, where agents are placed in controlled scenarios to see how they adapt. Continuous monitoring is also crucial because agents operate in dynamic environments where drift can degrade performance over time. How do you combine RAG with agents? RAG enhances agents by grounding their decisions in reliable data. Instead of hallucinating, an agent can retrieve domain-specific documents and then reason over them. For example, a customer support agent might fetch knowledge base articles before drafting an answer. In multi-turn reasoning, agents can even refine queries to improve retrieval quality. By combining RAG and agents, you get systems that are both adaptive and truthful, striking a balance between creativity and reliability. It's one of the most common production-ready architectures today. What is tool orchestration in agent systems? Tool orchestration is how agents decide which external tools to use, in what order, and with what parameters. For instance, a research agent may first call a search API, then run summarization, then generate a visual report. Orchestration frameworks like LangChain, Llama Index, or Microsoft's semantic kernel provide infrastructure for managing these sequences. The challenge is optimizing cost, latency, and accuracy, deciding whether to use a small model, call an API, or escalate to a more powerful model. Good orchestration is what makes agents efficient and trustworthy. What is the future of agentic AI? The future of agentic AI is systems that move from being reactive assistants to proactive collaborators. We'll see agents with stronger memory, better long-term planning, and the ability to work together in teams, almost like digital organizations. In enterprises, they'll automate multi-step workflows across sales, support, finance, and engineering. In consumer apps, they'll act as personalized co-pilots that anticipate needs. We're also moving toward embodied agents, robots that combine reasoning with physical action. Ultimately, the future is not one giant model, but a society of smaller specialized agents working together. How is generative AI used in healthcare? Generative AI in healthcare spans clinical decision support, drug discovery, and patient engagement. Models can generate synthetic medical data to protect privacy while training other systems. They're used to summarize medical literature, draft radiology reports, or simulate molecules in drug research. In patient-facing roles, generative chatbots provide 24/7 triage or mental health support. The key value is reducing clinician burden and accelerating R&D. However, deployment must follow strict compliance with HIPAA or GDPR, and outputs must be verified for accuracy before real-world use. What role does generative AI play in finance? In finance, generative AI helps generate synthetic datasets for fraud detection, create personalized financial advice, and automate reporting. For example, large language models can read through thousands of regulatory filings and generate summaries for analysts. They can also simulate scenarios for stress testing and risk analysis. On the customer side, chatbots provide personalized financial planning and faster support. Risks include regulatory scrutiny, explainability challenges, and preventing bias in generated recommendations, making governance frameworks essential. How can generative AI improve education? Generative AI enables personalized learning at scale. Tutors powered by LLMs can adjust explanations based on a student's level, generate practice problems, or provide instant feedback on essays. Models can summarize complex textbooks into simplified study notes or create quizzes tailored to a student's weaknesses. Beyond tutoring, teachers use AI to automate grading or draft lesson plans. The main challenge is ensuring accuracy, avoiding bias, and maintaining fairness in assessments. Done well, generative AI can democratize high-quality education globally. How is generative AI transforming creative industries? Creative industries, film, music, design are being reshaped by generative AI. Tools can generate movie storyboards, background music, or visual concepts, accelerating production cycles. Artists use diffusion models like Stable Diffusion or Midjourney as co-creators, iterating ideas faster. In gaming, AI can design characters, environments, or dynamic dialogue. The power lies in augmenting human creativity, not replacing it. The debate centers on intellectual property, ensuring AI doesn't plagiarize or exploit copyrighted work while still enabling creative freedom. How does generative AI support scientific research? Generative AI accelerates science by simulating experiments and generating hypotheses. For example, protein structure prediction, molecule generation, and material discovery benefit from generative models exploring vast design spaces faster than traditional methods. In astrophysics, models simulate galaxy formation. In climate science, they generate high-resolution predictions. The main advantage is cost and time savings. Researchers can test ideas virtually before moving to physical labs. However, reproducibility and validation remain critical, since errors in scientific AI outputs can mislead entire research directions. What is the role of synthetic data in generative AI? Synthetic data is artificially generated data that mimics real-world distributions. It's valuable when real data is scarce, sensitive, or imbalanced. Generative AI models can produce synthetic medical images, financial transactions, or customer interactions to augment training data sets. This improves model robustness while protecting privacy. For example, self-driving car companies use simulated environments to train vision systems. The risks are that synthetic data may not capture rare edge cases or may introduce bias if not carefully validated. How does generative AI impact customer support? Generative AI powers virtual agents that provide natural, personalized, and scalable customer support. Unlike traditional chatbots, they can handle open-ended questions, summarize customer history, and escalate intelligently. For example, an airline assistant can check flight status, process refunds, and explain policies conversationally. Beyond answering questions, they generate support articles and FAQs dynamically. The benefits are reduced costs and 24/7 coverage. However, safeguards are necessary to prevent misinformation, ensure handoff to humans, and maintain customer trust. What are common evaluation metrics for text generation? Text generation is evaluated using both automated and human-centric metrics. Automated metrics include perplexity for fluency, BLEU and ROUGE for overlap with reference text, and newer ones like BERT score for semantic similarity. However, automated scores often miss nuance. Human evaluation focuses on helpfulness, coherence, factual accuracy, and safety. Increasingly, organizations use preference models trained on human rankings to automate alignment checks at scale. In production, metrics like task success, latency, and customer satisfaction become as important as language quality. What are common evaluation metrics for image generation? For images, FID, Fréchet inception distance, is the gold standard. It measures similarity between generated and real distributions. Inception score evaluates diversity and recognizability, while CLIP score checks alignment with text prompts. Beyond numbers, human evaluation is critical for aesthetics, safety, and usability. Some platforms even train aesthetic scoring models to rank generations. For production, evaluation extends to robustness under adversarial prompts, safety filters, and business KPIs like engagement or ad performance. How do you test generative AI systems for safety? Testing for safety requires adversarial evaluation, red teaming the system with harmful or manipulative prompts. Models are tested for toxic language, biased outputs, misinformation, or security leaks. Automated classifiers help filter unsafe content, but human audits remain essential. Companies also simulate real-world misuse cases, like prompt injection attacks. Post-deployment, monitoring pipelines detect drift or unsafe outputs. The principle is defense in depth, multiple overlapping safeguards rather than relying on a single filter. How do you make generative AI outputs more trustworthy? Trust comes from grounding, transparency, and verification. RAG ensures outputs cite real documents. Confidence scoring communicates uncertainty. Schema enforcement ensures outputs match structured formats. Some systems watermark outputs to mark them as AI-generated. Human-in-the-loop review adds accountability for high-risk use cases like healthcare or finance. Ultimately, trust is built by combining accurate generation with clear provenance, showing not just the answer, but where it came from. How do you evaluate the business value of generative AI? Beyond technical metrics, companies measure ROI in terms of cost savings, efficiency, and user impact. For instance, did generative AI reduce average call handling time or increase developer productivity? Was customer satisfaction improved? A/B testing helps quantify gains. At scale, organizations track cost per token, percentage of resolved queries, and net promoter score. Evaluating business value ensures that AI investments deliver measurable returns, not just technological novelty. How can generative AI enhance marketing and personalization? Generative AI tailors content at scale, personalized emails, product descriptions, or ad creatives. By analyzing customer behavior, it generates targeted messages aligned with preferences. For example, an e-commerce platform can auto-generate product recommendations with unique descriptions for each user. Generative models also create images, videos, and copy variations for A/B testing. The result is higher engagement and conversion. Risks include over-automation, which may feel impersonal, so human oversight is key to balance efficiency with authenticity. What's the role of generative AI in law and compliance? In law, generative AI drafts contracts, summarizes case law, and assists in legal research. Compliance teams use it to monitor regulations, generate reports, and automate documentation. For example, a compliance assistant can summarize new financial rules and map them to existing policies. The challenge is accuracy. Legal outputs must be precise, so human verification is mandatory. Generative AI acts as a powerful paralegal, boosting efficiency but never replacing the final human judgment. How is generative AI applied in robotics? In robotics, generative AI enables robots to plan actions, simulate environments, and adapt to novel tasks. Language models can generate instructions that translate into robotic movements. Diffusion or reinforcement learning models generate synthetic environments to train robots virtually. For example, warehouse robots can be trained on AI-generated simulations before deployment. The benefit is faster learning and adaptability, but safety testing is critical. AI-driven robots must always operate within strict guardrails to prevent errors in physical environments. What is the difference between MLOps and LLMOps? MLOps focuses on deploying and maintaining traditional ML models, which are usually smaller, task-specific, and trained frequently. LLMOps, on the other hand, deals with large-scale foundation models. It emphasizes managing massive prompts, context windows, embeddings, RAG pipelines, and fine-tunes. LLMOps also requires monitoring hallucinations, bias, and token costs, things less prominent in classic ML. Essentially, MLOps ensures reliable pipelines, while LLMOps extends those practices to address scale, safety, and user-facing risks of large models. What challenges arise when deploying LLMs in production? Deploying LLMs comes with unique challenges: high compute costs, unpredictable latency, and difficulty in ensuring consistent outputs. There's also risk of hallucinations, data leakage, and adversarial attacks like prompt injection. Scaling across thousands of users means balancing throughput with quality. Observability is tough because outputs are unstructured and probabilistic. Organizations mitigate these by adding caching layers, RAG for grounding, guardrails, and fallback models to maintain reliability. How do you monitor a generative model in production? Monitoring involves three pillars: quality, safety, and cost. For quality, track task success rate, coherence, and customer satisfaction. For safety, log flagged outputs, bias, toxicity, hallucinations, and monitor red teaming metrics. For cost, measure tokens per request, latency, and cache hit rates. Dashboards typically integrate telemetry from both the model and orchestration layer. Continuous evaluation pipelines with test prompts ensure drift or regressions are caught before impacting users. What is model distillation, and how is it used with LLMs? Model distillation is the process of training a smaller model to mimic a larger one, capturing its knowledge while reducing size and cost. For LLMs, distillation is used to create lightweight assistants that run faster and cheaper, sometimes on edge devices. For example, a distilled chatbot might deliver 80% of GPT-4's quality at a fraction of the cost. Distillation helps scale generative AI by democratizing access and optimizing latency-sensitive applications. How do you handle latency issues in large models? Latency can be tackled at several layers. Use retrieval to reduce context size and caching to avoid recomputing repeated responses. Streaming partial outputs improves user experience. Distilled or smaller models can handle common queries, with larger models reserved for complex ones. On infrastructure, batching requests and deploying on GPUs/TPUs improves throughput. In critical apps, hybrid architectures balance responsiveness with depth, ensuring users never wait unnecessarily. What is prompt caching and why is it important? Prompt caching saves the results of frequently used prompts, so they don't need to be recomputed. For example, a financial assistant repeatedly asked about interest rate policies could cache that response. This reduces token costs and improves latency dramatically. Enterprise deployments often cache embeddings, context retrievals, and partial generations. It's one of the simplest yet most impactful cost optimizations in LLM ops. How do you manage costs when scaling generative AI systems? Cost management involves tracking token budgets, using prompt optimization, and routing queries to the smallest capable model. Cascaded model architectures ensure only hard queries hit the largest model. Compression techniques like LoRa and quantization reduce fine-tuning costs. In addition, caching and deduplication prevent waste. Enterprises often run ROI dashboards, measuring cost per query against business value. This ensures AI investments scale sustainably. What role does quantization play in LLM efficiency? Quantization reduces the precision of model weights, like going from 16-bit to 8-bit or even 4-bit without losing much accuracy. This drastically lowers memory usage and speeds up inference. It's critical for deploying large models on limited hardware or mobile devices. Combined with pruning or distillation, quantization enables practical real-world scaling. The trade-off is small performance loss, but it's usually worth it for efficiency. How do you implement guardrails in generative AI systems? Guardrails ensure safe and compliant outputs. They include input filters to block harmful prompts, output filters to catch unsafe content, schema enforcement to restrict responses to formats, and RAG for grounding in trusted sources. Some frameworks use safety classifiers to re-rank or block outputs before release. Guardrails are layered, like cybersecurity defenses. This approach minimizes harmful edge cases, ensuring trust in real-world applications. What is human in the loop, and why is it needed? HITL means involving human reviewers in the AI workflow. For high-stakes areas like healthcare, law, or finance, AI can draft outputs, but humans verify them before action. This balances efficiency with accountability. For example, a contract generator may draft legal terms, but a lawyer approves them. HITL also helps gather feedback for retraining, improving alignment over time. It's an essential safeguard against over-reliance on automation. What are drift and degradation in LLMs? Drift happens when the data distribution shifts, like new slang or regulations emerging, that the model wasn't trained on. Degradation is the gradual decline in performance due to mismatched context, new edge cases, or evolving user needs. Both can cause LLM outputs to become less accurate or relevant. Continuous evaluation, feedback loops, and retraining or fine-tuning are critical to combat drift and keep models useful. How do you integrate generative AI with legacy systems? Integration often requires wrapping legacy APIs with middleware that the model can call. For example, instead of retraining on old ERP systems, an agent can generate structured queries that interact with those systems. Tools like RAG help bring structured enterprise knowledge into the model's context. The challenge is ensuring reliability and security, especially when connecting AI to systems not originally built for automation. What's the difference between batch and real-time inference in generative AI? Batch inference processes large sets of inputs offline, like generating summaries for thousands of documents overnight. Real-time inference responds immediately to user queries, like a chatbot conversation. Batch is cost-efficient and useful for pre-computation. Real-time requires low latency and scalability. Most enterprises use a mix, batch for preparation and real-time for customer-facing interactions. How do you ensure compliance when deploying generative AI? Compliance requires controlling data flows, ensuring privacy, and maintaining audit logs. Sensitive data must be anonymized or excluded from prompts. Outputs must be filtered for regulatory alignment, for example, avoiding unapproved financial advice. Enterprises implement access controls, encryption, and regular audits. Documentation and explainability help satisfy regulators. Without compliance guardrails, even technically, strong systems can't be deployed legally in sensitive industries. What is the role of observability in LLM ops? Observability means having visibility into how generative AI behaves in the wild. This includes logging prompts, outputs, errors, token usage, and latency. Dashboards track key metrics like cost per query, hallucination rates, and safety violations. Observability tools help detect anomalies early, like a spike in harmful outputs or a surge in costs. Without observability, you're flying blind. With it, you can diagnose, improve, and scale responsibly. What are the ethical challenges of generative AI? The biggest challenges are misinformation, bias, and misuse. Generative AI can produce convincing but false information, potentially spreading disinformation at scale. Models may also inherit or amplify biases present in training data, which can harm marginalized groups. Intellectual property is another concern, using copyrighted data without attribution. Finally, there's the human impact, job displacement, and over-reliance on automation. Ethical deployment requires balancing innovation with fairness, transparency, and accountability. How do you identify bias in generative AI outputs? Bias can appear in subtle ways. Language reflecting stereotypes, unequal treatment across demographics, or skewed data representation. To detect it, organizations run audits with diverse test prompts, measure differences in output quality, and analyze embeddings for imbalances. Red teaming with experts from different backgrounds often reveals hidden biases. Automated fairness metrics help, but human review remains critical. The goal isn't only spotting bias, but actively reducing its harmful impact. What methods exist to mitigate bias in generative models? Bias mitigation happens at 3 stages. In data curation, we filter or balance datasets. In training, we apply debiasing objectives or reinforcement from human feedback to penalize biased responses. Post-training, we add safety filters, re-rankers, or retrieval grounding to steer outputs toward fairness. No method is perfect, so the best practice is combining them. Transparency and ongoing audits ensure the system stays fair as it evolves. What is model alignment in generative AI? Model alignment means ensuring outputs are consistent with human values, goals, and safety requirements. Pre-trained models generate based on data patterns, not ethics. Alignment techniques like ARM, LHF, constitutional AI, or preference modeling steer models toward producing helpful, harmless, and honest answers. Alignment is especially important for public-facing systems where trust is critical. Without alignment, even the most capable models risk being misused or generating harmful content. What is constitutional AI, and how does it differ from RLHF? Constitutional AI is an alignment approach where models follow a written set of principles, like a constitution, instead of relying only on human ratings. For example, Anthropic trains models to critique and revise their own outputs using constitutional rules. RLHF, in contrast, depends on human feedback to rank outputs and train a reward model. Constitutional AI scales alignment more efficiently, while RLHF captures nuanced human preferences. Many organizations combine both methods. What is red teaming in generative AI? Red teaming means stress testing models by probing them with adversarial prompts. The goal is to uncover harmful, biased, or unsafe behaviors before deployment. Teams simulate worst-case scenarios, like trying to bypass safety rules or generate disallowed content. Insights from red teaming feed into retraining, guardrails, and safety filters. It's an ongoing process, not a one-time step, because adversarial techniques evolve as quickly as the models. How do you balance creativity and safety in generative AI? The balance comes from tuning model freedom. High-temperature or open-ended prompts maximize creativity but increase risk of unsafe outputs. Adding constraints like schemas, retrieval grounding, or content filters ensures safety but can limit creativity. The best practice is contextual. In art, loosen controls. In healthcare, tighten them. Many systems combine tiered controls, safe defaults for the public, Flexible modes for experts. The art is designing boundaries that inspire innovation without compromising safety. What is explainability in generative AI, and why is it difficult? Explainability means making a model's reasoning process understandable to humans. In classic ML, we can visualize decision trees or weights. In LLMs, billions of parameters and emergent behavior make explanations harder. Outputs look coherent, but the reasoning is statistical, not causal. Techniques like attention heat maps, attribution, and reasoning traces help, but they're imperfect. The difficulty is that we're trying to interpret a black box that wasn't designed to explain itself. How do you ensure data privacy in generative AI systems? Privacy is critical, especially when prompts contain sensitive information. Strategies include anonymizing data before training, excluding personal identifiers, and applying differential privacy. At inference time, prompts and outputs must be logged securely and access controlled. Some systems use retrieval from private databases, rather than exposing raw data to the model. Compliance with GDPR or HIPAA is mandatory in regulated industries. Strong privacy protections build trust with both users and regulators. What is differential privacy, and how does it apply to large language models? Differential privacy adds controlled noise to data or outputs, ensuring individual records cannot be reverse engineered. In LLMs, it's used during training to prevent memorization of sensitive data. This means even if the model saw a private record, it won't reveal it verbatim. Differential privacy balances utility with confidentiality, especially important in healthcare and finance. The trade-off is a slight reduction in accuracy, but it's necessary for compliance and trust. How do you prevent misuse of generative AI? Prevention involves both technical and policy layers. Technically, you add filters, guardrails, and rate limits to block harmful or abusive use. On the policy side, terms of service restrict applications like disinformation or deepfake creation. Detection systems monitor suspicious behavior, and abuse reports trigger investigation. Ultimately, it's about anticipating how the technology could be exploited and designing safeguards from day one. Prevention is continuous since misuse tactics evolve over time. What are the risks of deepfakes created by generative AI? Deepfakes can be entertaining, but they also pose serious risks. They can be used for misinformation, fraud, impersonation, or harassment. Politically, they can destabilize trust in media. On a personal level, they threaten reputation and privacy. To counter these risks, watermarking, detection models, and legal frameworks are being developed. While deepfakes showcase the power of generative AI, they highlight why responsible use and verification are so important. What is AI watermarking, and how does it work? AI watermarking embeds invisible signals in generated content to mark it as AI-made. In text, this might involve statistical patterns in token selection. In images, slight pixel-level modifications. These marks aren't visible to users, but can be detected by verification tools. Watermarking helps fight misinformation and establishes accountability. The challenge is making watermarks robust against tampering, while balancing utility and detectability. How can generative AI support responsible journalism? Generative AI assists journalists by drafting summaries, generating headlines, or transcribing interviews. It can also analyze large document sets to surface insights. However, it must be used responsibly. Journalists should treat AI as an assistant, not a sole author. Outputs need fact-checking and source attribution. Some newsrooms use AI to speed up workflows while maintaining editorial standards. The key is transparency with audiences about when and how AI contributed. What governance frameworks exist for generative AI? Governance frameworks guide responsible AI use. The EU's AI Act, the US AI Bill of Rights, and OECD principles emphasize transparency, accountability, and safety. Many companies also adopt internal responsible AI policies covering fairness, explainability, and security. Governance means setting rules for data sourcing, model training, deployment, and monitoring. Without clear frameworks, organizations risk legal penalties and loss of public trust. Strong governance is both a compliance requirement and a competitive advantage. What are foundation models and why are they important? Foundation models are large-scale, general-purpose models trained on massive data sets such as GPT or Claude. They provide a flexible base that can be adapted to many downstream tasks through fine-tuning, RAG, or prompting. Their importance lies in scalability rather than training a new model for every task. Companies adapt a single foundation model for multiple use cases. This reduces cost, accelerates innovation, and standardizes infrastructure. They're essentially the operating systems of modern AI. What are emergent abilities in LLMs? Emergent abilities are capabilities that appear in large models, but not in smaller ones. For example, smaller models struggle with arithmetic or multi-step reasoning, while larger ones suddenly demonstrate them without explicit training. This happens because scale allows models to capture deeper patterns in data. Emergence shows that some skills aren't hard-coded, but arise from model complexity. It's both exciting and challenging, since predicting what abilities will emerge is still an open research question. How do multimodal models change the landscape of AI? Multimodal models process and generate across text, images, audio, and video. Instead of siloed systems, a single model can understand a chart, describe it, and answer questions about it. This makes AI more human-like, since we interact through multiple modalities. In practice, multimodality enables richer assistance, creative tools, and cross-domain applications, like analyzing medical scans with patient notes. It also expands accessibility, supporting users who prefer voice, vision, or text interactions. What are agentic workflows, and why are they important? Agentic workflows refer to systems where AI agents break tasks into steps, use tools, and adapt dynamically to achieve goals. Unlike static prompting, agents plan, execute, and adjust in loops. This is important because real-world tasks rarely fit into one-shot prompts. For example, a research agent might search, summarize, refine queries, and synthesize findings iteratively. Agentic workflows are key to moving from passive assistance to autonomous collaborators. How is generative AI evolving in enterprise settings? In enterprises, generative AI is moving from pilots to full production. Early use cases were chatbots and copilots, but now it's expanding into document processing, compliance, sales automation, and decision support. Enterprises prioritize trust, so RAG, fine-tuning, and governance frameworks are critical. We're also seeing domain-specific foundation models, trained for law, healthcare, or finance. The future in enterprise is less about flashy demos and more about reliable, secure systems integrated into workflows. What role does synthetic biology play in generative AI? Generative AI is being applied to synthetic biology, where models generate protein sequences, design enzymes, or simulate genetic pathways. Diffusion-like models explore chemical spaces to propose new drug candidates. For example, AI-designed proteins have already advanced biotech pipelines. The advantage is speed, exploring billions of possible molecules virtually before lab testing. The risks include over-optimism and the need for careful validation, since errors could have real biological consequences. What are personalized foundation models? Personalized foundation models adapt general-purpose AI to individual users. They might learn from a person's emails, documents, or preferences to tailor outputs. Imagine a personal AI assistant that not only knows language broadly, but understands your style, tone, and routines. Techniques include retrieval, fine-tuning on private data, or lightweight adapters. The challenge is balancing personalization with privacy, ensuring sensitive data isn't leaked or misused. Done right, personalization makes AI far more useful day to day. What is federated learning, and how does it apply to generative AI? Federated learning trains models across decentralized devices without centralizing data. Each device trains locally and shares updates, not raw data, preserving privacy. For generative AI, this allows personalization without compromising confidentiality, for example. Adapting a keyboard prediction model across smartphones without sending personal messages to a server. It's valuable in healthcare and finance, where data privacy is critical. The trade-off is slower training and the challenge of aggregating updates across diverse devices. How are small language models competing with large ones? While large models grab headlines, small models are gaining traction due to efficiency and cost. With fine-tuning, distillation, and RAG, smaller models can achieve competitive performance for many tasks. For example, a 7B parameter model might handle customer support as effectively as a 70B model at a fraction of the cost. This shift is important because it democratizes access. Organizations without massive compute budgets can still deploy strong AI. It's a trend toward right-sized models. What is the role of open source in generative AI? Open source models like LLMA, Mistral, and Falcon are reshaping the landscape. They give organizations flexibility, transparency, and cost control compared to closed APIs. Open source enables rapid experimentation, customization, and peer-reviewed safety practices. Enterprises often deploy open models when data sovereignty or compliance requires full control. The trade-off is more responsibility for hosting, fine-tuning, and safety. Overall, open source is accelerating innovation and balancing the influence of big tech players. What is the difference between zero-shot and few-shot prompting? Zero-shot prompting asks a model to perform a task with no examples, relying solely on instructions. Few-shot prompting provides a handful of examples in the prompt to guide output style or reasoning. For instance, asking a model to translate with no samples is zero-shot, but giving two translations first is few-shot. Few-shot often improves accuracy by anchoring the model's behavior. Both are foundational techniques in leveraging LLMs without fine-tuning. What is chain of thought prompting, and why is it powerful? Chain of thought prompting instructs models to reason step by step, rather than jumping to an answer. This mirrors human problem solving and improves performance on arithmetic, logic, and multi-step reasoning. For example, instead of asking, "What's 37 times 24?" directly you say, "Explain your reasoning." The model breaks it into steps, reducing errors. It's powerful because it unlocks latent reasoning abilities. Though care is needed, models can still produce faulty reasoning chains. What is self-consistency in prompting? Self-consistency is a decoding strategy where the model generates multiple reasoning paths, then selects the most consistent answer. Instead of relying on one chain of thought, you sample several and take the majority outcome. This boosts accuracy, especially in math and reasoning tasks, because errors in individual chains are averaged out. It's like having multiple problem solvers and trusting the consensus. The trade-off is higher compute costs, but the quality gains are significant. What is recursive prompting, and when is it used? Recursive prompting means feeding the model's own outputs back as inputs for refinement. It's like asking the model to critique and improve itself iteratively. For example, you might say, "Draft a summary. Now review it for clarity, now shorten it." This self-improvement loop reduces errors and increases quality. It's especially useful for long-form generation, where polishing is as important as drafting. The risk is drift if not guided carefully, so guardrails are essential. What are the future trends in generative AI for the next 5 years? The next 5 years will bring multimodal AI mainstream, models that seamlessly handle text, image, audio, and video. Agents will become more autonomous, managing workflows end-to-end across enterprise tools. Personalization will grow, with AI tailored to individuals while protecting privacy. Efficiency improvements will make small, specialized models widely available. Regulation and governance will mature, balancing innovation with responsibility, and we'll see integration into physical systems, robots, IoT, and AR/VR, blurring the line between digital and real worlds. What is knowledge distillation in generative AI? Knowledge distillation transfers knowledge from a large teacher model into a smaller student model. The student learns not only from ground truth labels, but also from the teacher's output distributions, capturing richer patterns. In generative AI, this allows organizations to deploy smaller, faster models that mimic the performance of larger ones. For example, a distilled chatbot might replicate GPT-4 quality at a fraction of the cost. Distillation is key for scaling generative AI to edge devices or high-volume applications. What are Retrieval-Augmented Transformers, RATS? Retrieval-Augmented Transformers integrate retrieval directly into the model's architecture. Instead of relying only on context windows, the model fetches relevant documents during generation. This makes it more scalable and reduces hallucinations. Unlike external RAG pipelines, RATS are end-to-end, with retrieval and generation trained jointly. They're promising for domains where accuracy and grounding are critical, like legal research or scientific discovery, since the model learns to retrieve and cite information as part of its workflow. What is parameter-efficient fine-tuning, PEFT, and why does it matter? PEFT methods such as LoRa, adapters, or prefix tuning update only a small fraction of parameters instead of the entire model. This makes fine-tuning faster, cheaper, and more storage efficient. It's important because foundation models are massive. Updating billions of parameters isn't feasible for most organizations. With PEFT, companies can maintain multiple domain-specific variants without retraining from scratch. It democratizes access, letting smaller teams build powerful, specialized systems. How do mixture of experts models work? Mixture of experts models split the network into multiple expert modules, but only a subset is activated per input. A gating network decides which experts to use. This makes training and inference more efficient because not all parameters are engaged at once. For generative AI, MoE architectures allow models to scale to hundreds of billions of parameters while keeping compute manageable. The challenge is balancing load across experts and avoiding specialization collapse. What is the role of reinforcement learning in generative AI beyond RLHF? Beyond alignment, reinforcement learning can optimize models for efficiency, diversity, and robustness. For example, in dialogue agents, reinforcement learning improves engagement by rewarding longer, helpful conversations. In creative domains, it encourages originality by rewarding diverse outputs. Reinforcement learning is also used in simulations, where models generate strategies and receive rewards based on success. The key is designing reward functions carefully. Poorly chosen signals can push models in unintended directions. How do diffusion models compare to autoregressive models in text generation? Autoregressive models like GPT generate text token by token, ensuring coherence and fluency. Diffusion models, though more common in vision, are being explored for text by iteratively denoising latent representations. Autoregression excels at sequential prediction, but diffusion can provide more global control, such as better diversity and paraphrasing. While autoregressive models dominate text today, hybrid approaches combining autoregression with denoising may emerge, balancing coherence with creativity. What is active learning, and how can it help generative models? Active learning selects the most informative data samples for labeling and training. Instead of labeling everything, the model identifies where it's most uncertain. In generative AI, active learning ensures fine-tuning data is high value, covering edge cases, factual gaps, or safety-sensitive areas. For example, if a chatbot struggles with regulatory questions, active learning prioritizes those examples. This reduces training costs while improving robustness in weak areas. What are retrieval-enhanced evaluation methods for generative AI? Traditional metrics like BLEU or FID don't always capture factual correctness. Retrieval-enhanced evaluation compares generated outputs against trusted sources dynamically. For instance, a model's answer can be cross-verified against a retrieval pipeline, flagging hallucinations. This is especially useful in enterprise or compliance contexts, where accuracy matters more than fluency. By grounding evaluation in retrieval, companies measure not just plausibility but factual alignment, which is critical for production. What is continual learning in generative AI? Continual learning means updating a model incrementally without retraining from scratch. In generative AI, this is important because knowledge changes, laws, medical guidelines, or product catalogs evolve. Techniques include parameter isolation, rehearsal with old data, or adapters that capture new knowledge. The challenge is avoiding catastrophic forgetting, where the model loses past skills. Continual learning ensures generative systems stay current and useful without incurring the cost of full retraining. How do you debug a generative model producing poor outputs? Debugging requires breaking the problem down. First, analyze whether the issue is data, prompting, or decoding. Poor fluency might mean tokenization or context truncation problems. Hallucinations suggest missing grounding or weak retrieval. Bias might stem from training data imbalances. Tools like prompt tracing, log analysis, and ablation studies help isolate issues. Sometimes the solution is as simple as refining prompts. Other times it requires fine-tuning or architectural changes. The key is systematic diagnosis. What is meta-learning, and how does it relate to generative AI? Meta-learning, or learning to learn, trains models to adapt quickly to new tasks with minimal data. In generative AI, it's what enables few-shot and zero-shot generalization. Instead of retraining, the model leverages prior learning to generalize on the fly. For example, given just a few examples of a new writing style, the model can mimic it. Meta-learning makes generative AI flexible, especially in environments where tasks or data distributions change frequently. How does curriculum learning improve generative training? Curriculum learning means presenting training data in a structured progression, from simple to complex. In generative AI, this helps models stabilize during training. For example, starting with short sequences before scaling to long documents reduces instability in language modeling. In diffusion, training on easy denoising steps before harder ones improves convergence. It mirrors human learning, mastering basics first before tackling harder problems. The result is smoother training and better generalization. What are memory-augmented neural networks? Memory-augmented networks incorporate external memory modules into models, allowing them to store and retrieve information explicitly. For generative AI, this means longer-term recall beyond context windows. For example, a chatbot could remember user preferences across months. Architectures like neural Turing machines or differentiable memory access have been explored. While challenging to scale, memory-augmented systems represent a step toward AI that learns continuously and remembers like humans. What is gradient checkpointing, and why is it useful in large models? Gradient checkpointing reduces memory usage during training by saving fewer activations and recomputing them during backpropagation. For massive generative models, training without it would exceed GPU memory limits. Checkpointing trades off compute for memory slowing training slightly, but enabling much larger models to fit into available hardware. It's one of the core tricks that made training billion-parameter models feasible with today's GPUs. What are hypernetworks, and how do they relate to generative AI? Hypernetworks are models that generate weights for another model dynamically. Instead of storing static weights, a hypernetwork outputs parameters conditioned on context. In generative AI, hypernetworks allow adaptation without retraining. For example, producing a new style of text generation on demand. They're also used in personalization, where user-specific embeddings guide the hypernetwork to adjust outputs. While still experimental, hypernetworks point toward more flexible, adaptive generative systems. How is generative AI transforming supply chain management? Generative AI helps optimize supply chains by simulating demand, generating forecasts, and suggesting alternative logistics routes. It can create what-if scenarios to test disruptions, like factory delays or geopolitical risks. For procurement, it drafts supplier contracts or negotiates terms using agent-based systems. The benefit is adaptability and resilience. Businesses can respond faster to uncertainty. Risks include over-reliance on synthetic forecasts, so human oversight remains critical. What's the role of generative AI in cybersecurity? Generative AI strengthens cybersecurity by simulating attacks, generating synthetic malware for training, and drafting incident response playbooks. It can also analyze logs, summarize threat reports, and generate detection rules. On the flip side, attackers can use generative models to craft phishing emails or obfuscate malware. That's why defensive and offensive use cases grow in parallel. Responsible deployment requires careful monitoring to avoid empowering adversaries while strengthening resilience. How can generative AI help sustainability efforts? Generative AI supports sustainability by optimizing energy use, simulating climate scenarios, and generating efficient designs. For example, AI can propose novel battery chemistries or suggest eco-friendly packaging designs. Companies use it to generate synthetic datasets for carbon impact analysis or draft ESG reports. While AI itself consumes energy, research into efficient architectures and green AI practices aims to balance innovation with sustainability goals. What impact does generative AI have on software engineering? Generative AI is reshaping software engineering with code generation tools like Copilot. Developers use it to autocomplete functions, generate tests, and even refactor legacy code. It accelerates onboarding by generating documentation and translating between languages. The risk is over-reliance. AI can suggest insecure or inefficient code. Best practice is treating it as an assistant, boosting productivity while ensuring developers review and validate outputs. How is generative AI used in drug discovery? Drug discovery benefits greatly from generative AI. Models generate molecular structures, simulate interactions, and propose new compounds with desired properties. Diffusion and graph-based models explore chemical space faster than traditional lab work. For example, AI can propose candidate drugs for rare diseases in weeks instead of years. The challenge is validation. Lab testing and clinical trials remain essential. Generative AI accelerates discovery but doesn't replace rigorous science. What are generative design systems in engineering? Generative design uses AI to automatically propose multiple design solutions given constraints, like weight, cost, or strength. In aerospace, it designs lightweight parts with unique geometries. In architecture, it generates floor plans optimized for light and airflow. The AI doesn't pick one design, but provides options for engineers to refine. The value is creativity at scale, uncovering designs humans might not imagine. However, manufacturability and compliance checks are always needed. How is generative AI used in personalized marketing? Generative AI personalizes marketing by tailoring content, emails, ads, or product descriptions to individual preferences. It analyzes customer behavior and generates targeted messaging, boosting engagement. For example, an e-commerce site can auto-generate ad creatives matching each user's browsing history. AI also generates A/B test variants at scale, accelerating optimization. The challenge is avoiding creepy personalization, ensuring transparency and respecting privacy boundaries. How can generative AI enhance education accessibility? Generative AI breaks barriers in education by providing real-time translations, simplifying complex materials, and creating adaptive learning paths. It generates audio, Braille-friendly content, or visual explanations for different learners. For underserved communities, AI tutors offer 24/7 guidance where teachers are scarce. While it democratizes education, the challenge is equity, ensuring resources reach marginalized groups and avoiding bias that could disadvantage learners further. How does generative AI intersect with AR and VR? Generative AI powers AR and VR by creating dynamic 3D assets, environments, and narratives in real time. In gaming, it generates unique characters or levels tailored to players. In enterprise, it builds immersive training simulations. Imagine AR glasses that generate contextual overlays in the real world. This fusion creates personalized, adaptive experiences. The challenge is real-time efficiency. Generative pipelines must be optimized for latency-sensitive, immersive systems. What are conversational agents with multi-turn memory? Conversational agents with multi-turn memory can recall previous interactions, user preferences, and context across sessions. Unlike stateless bots, they build continuity, like remembering you prefer concise answers or tracking project progress. This requires memory architectures, vector databases, or external storage tied to conversations. Multi-turn memory makes agents feel more human-like and useful in tutoring, coaching, or personal assistant roles. The challenge is ensuring privacy and controlling what is remembered. How is generative AI used in journalism? In journalism, generative AI drafts news summaries, creates headlines, and analyzes large datasets like leaks or reports. It transcribes interviews and suggests story angles. Some outlets experiment with AI-assisted article drafting, though human editors ensure accuracy. The benefit is speed and efficiency, freeing journalists to focus on investigation and analysis. The challenge is credibility. AI cannot replace fact-checking or editorial judgment. Transparency about AI's role is key to maintaining trust. What are the risks of over-reliance on generative AI in the workplace? Over-reliance can erode human expertise. Employees may lose critical thinking or problem-solving skills if they always defer to AI. It can also create false confidence. AI outputs may sound authoritative, but contain errors. This risk is highest in regulated industries where accuracy is non-negotiable. Organizations mitigate this by using AI as an assistant, not a replacement, and requiring human oversight. Building AI literacy among workers helps maintain balance. How does generative AI affect intellectual property IP law? Generative AI challenges IP law because outputs may resemble copyrighted works and training data. Who owns AI-generated content, the user, the developer, or nobody? Courts are grappling with these questions. Some jurisdictions deny copyright protection for AI-only creations, while others allow it if there's significant human input. Enterprises must set clear policies on ownership, licensing, and attribution. IP law will likely evolve alongside generative AI's growth. What are AI-native applications, and how do they differ from AI-enabled apps? AI-enabled apps add AI as a feature. For example, a writing tool that integrates text generation. AI-native apps, by contrast, are built entirely around AI as the core experience. Examples include Jasper, Midjourney, or Character.ai. They rethink workflows around generative capabilities rather than bolting AI onto existing systems. AI-native apps often unlock new categories of products, while AI-enabled apps enhance existing ones. The distinction matters for product strategy and competitive positioning. How will generative AI impact the future of work? Generative AI will shift work from repetitive execution toward higher-level creativity and strategy. Routine tasks, drafting emails, summarizing reports, generating code, will be automated, freeing humans to focus on problem-solving and innovation. New roles will emerge like AI trainers, auditors, and ethicists. At the same time, some jobs will be disrupted, requiring reskilling. The future of work will be hybrid, humans plus AI co-pilots working together. Success depends on how organizations balance productivity with workforce adaptation. How is generative AI applied in autonomous vehicles? Generative AI helps simulate driving scenarios, generate synthetic sensor data, and model edge cases that are rare in real life. For example, it can create unusual weather or traffic situations to train perception systems. It's also used to generate realistic dialogue for in-car assistance. The advantage is safer and more robust systems before the road testing. The challenge is ensuring synthetic data doesn't overfit models to unrealistic conditions. What role does generative AI play in gaming? In gaming, generative AI creates dynamic narratives, characters, and environments. Instead of static storylines, non-player characters can generate dialogue in real time, adapting to player actions. AI can also generate entire levels procedurally, increasing replay value. This reduces development time while enhancing creativity. However, balancing AI-driven unpredictability with consistent game design remains a key challenge. How does generative AI support legal discovery? During legal discovery, lawyers sift through vast documents. Generative AI summarizes contracts, identifies relevant clauses, and drafts briefs. It reduces manual workload by generating insights across thousands of pages. AI can also simulate case strategies by generating possible arguments. Accuracy is critical, so human lawyers always verify outputs. The benefit is speed and cost savings, but compliance and accountability remain paramount. What are graph generative models and why are they important? Graph generative models create new graphs, networks of nodes and edges, such as molecules, social networks, or financial systems. They're important because many real-world problems are graph-structured. For instance, in chemistry, AI can generate molecular graphs with desired properties. In cybersecurity, it can simulate attack graphs. These models combine deep learning with structural reasoning, enabling generative AI to extend beyond text and images into relational domains. How does generative AI intersect with the Internet of Things (IoT)? Generative AI augments IoT by generating predictive maintenance insights, summarizing sensor data, and simulating future states. For example, it can generate maintenance schedules based on IoT readings or simulate anomalies before they occur. Combined with edge deployment, generative AI provides localized decision-making, like predicting equipment failure in factories. The challenge is balancing compute needs with IoT devices' limited hardware. How can generative AI accelerate product design? Generative AI proposes multiple design prototypes quickly based on constraints like cost, material, or ergonomics. For example, consumer electronics companies use it to generate hundreds of product shell variations before prototyping. Designers then refine the best ones. This speeds up iteration cycles and sparks creativity. The limitation is ensuring designs are practical for manufacturing. AI can propose ideas that look good but aren't feasible. How is generative AI used in climate modeling? Generative AI downscales coarse climate models into fine-grained predictions, simulates weather events, and generates synthetic datasets for training. This enables more accurate forecasting at regional levels. For example, I can simulate hurricane paths with higher resolution than traditional physics-based models. The challenge is validation. AI must complement, not replace, physical models to ensure scientific credibility in climate policy decisions. What are neurosymbolic generative models? Neurosymbolic models combine deep learning with symbolic reasoning. For generative AI, this means combining pattern recognition with rule-based logic. For example, an AI could generate a math proof that both follows symbolic rules and uses learned reasoning patterns. This hybrid approach is powerful in domains like law, science, or math, where creativity must be grounded in strict rules. It's a step toward more interpretable and reliable generative systems. How is generative AI integrated with robotics for manufacturing? Generative AI helps robots learn new skills by simulating tasks virtually before execution. It generates synthetic environments to train robotic arms or autonomous forklifts. AI can also generate optimized assembly sequences. This reduces trial and error costs in factories. The challenge is bridging simulation and reality, known as the sim to real gap. Careful calibration ensures robots trained in AI-generated environments perform reliably in the physical world. How does generative AI intersect with quantum computing? Quantum computing offers new ways to train generative models by exploring probability distributions more efficiently. Conversely, generative AI helps design quantum algorithms and simulate quantum systems. For example, AI can generate candidate molecules that quantum computers then analyze in detail. While still experimental, this intersection could accelerate both fields: quantum for compute power, AI for intelligent exploration. The main challenge is scalability and practicality, as both are still early-stage technologies. How does generative AI enhance knowledge management? Generative AI organizes, summarizes, and contextualizes enterprise knowledge bases. Employees can query natural language and get synthesized answers across wikis, PDFs, and emails. It also generates meeting notes and action summaries automatically. By embedding and retrieving knowledge, AI reduces information overload. The risk is hallucination, so grounding in enterprise data is essential. Properly implemented, it transforms organizational memory into a living, accessible resource. What are generative adversarial imitation learning, GAIL techniques? GAIL combines GANs with imitation learning. Instead of generating images, the model generates policies by imitating expert behavior. It's used in robotics and reinforcement learning to teach agents without explicit reward signals. For example, a robot can learn to walk by imitating expert demonstrations. GAIL is powerful because it leverages generative models for structured behaviors, not just data outputs. The challenge is training stability and ensuring policies generalize well. How does generative AI help in fraud detection? Generative AI creates synthetic fraudulent transactions to train discriminative fraud detectors. By generating realistic but fake fraud cases, detectors become more robust. AI also generates adversarial scenarios to stress test systems. Beyond detection, it summarizes suspicious activity reports for investigators. The challenge is avoiding misuse. Fraudsters could also leverage generative AI to evade detection. Controlled deployment ensures the benefits outweigh risks. What role does generative AI play in personalized healthcare? Generative AI personalizes healthcare by generating treatment recommendations tailored to patient histories. It can simulate likely outcomes of therapies, draft personalized wellness plans, or generate diet suggestions based on genomic data. In mental health, conversational AI provides customized support. The challenge is ensuring safety. Personalized advice must be verified by medical professionals. AI provides augmentation, not replacement, of human care. What are the limitations of current generative AI systems? Despite their power, current systems face limitations. They hallucinate facts, lack true reasoning, and depend heavily on training data quality. They also have context window limits, struggling with very long documents or conversations. Scaling costs and latency are major barriers for real-time use. Ethically, bias and misuse remain unsolved. While they simulate understanding, they don't know in a human sense. These limitations guide research into retrieval, reasoning, and more efficient architectures. How is generative AI applied in space exploration? Generative AI helps simulate planetary environments, generate synthetic satellite data, and design spacecraft components. For example, AI can generate terrain models for Mars rovers or simulate communication delays for mission planning. It can also assist in generating new materials optimized for space conditions. The main benefit is accelerating research and testing scenarios virtually before committing to costly missions. The challenge is ensuring models are validated against real-world physics. How can generative AI improve accessibility for people with disabilities? Generative AI creates personalized tools for accessibility, like real-time captioning, text-to-speech, or summarizing complex documents into simpler formats. It generates alt text for images or creates sign language avatars from video. For visually impaired users, it can narrate the web interactively. The goal is inclusivity, breaking barriers in communication and access. The challenge is accuracy and sensitivity, ensuring outputs are respectful and truly supportive. How does generative AI intersect with human creativity? Generative AI acts as a co-creator, expanding human creativity rather than replacing it. Musicians use it to generate melodies, writers use it for brainstorming, and artists explore visual variations. It accelerates iteration and opens new creative possibilities. The tension lies in originality. Does AI-generated art dilute human authorship? The best use is augmentation. Humans provide intent and curation, while AI expands the creative horizon. What are the risks of generative AI and misinformation? Generative AI can produce convincing fake news, images, or videos at scale. This amplifies misinformation risks, undermining trust in media and institutions. The danger is not just false content, but overwhelming people with so much synthetic media that truth becomes uncertain. Countermeasures include watermarking, content authentication, and public education in media literacy. Misinformation is one of the most urgent societal risks of generative AI. How is generative AI used in voice cloning? Voice cloning uses generative models to replicate human voices from small audio samples. It's applied in entertainment, accessibility, and personalized assistance. For example, AI can generate audiobooks in an author's voice or restore speech for patients. The risks are impersonation and fraud. Scams using cloned voices are already a concern. Responsible deployment requires consent, watermarking, and safeguards against malicious use. What are multimodal agents, and how do they differ from unimodal ones? Multimodal agents process and generate across different data types, text, images, audio, or video, while unimodal agents focus on one. A multimodal agent could read a diagram, explain it, and generate code based on it, whereas a unimodal text agent only handles language. Multimodal systems are more natural for humans, who combine senses seamlessly. They expand use cases in healthcare, education, and creative fields. The challenge is aligning modalities effectively without losing performance. What is compositional generalization in generative AI? Compositional generalization is the ability to combine known concepts in novel ways. For example, if a model knows red square and blue circle, can it generate blue square? Humans do this effortlessly, but AI often struggles. It's critical for reasoning, creativity, and adaptability. Research in structured prompting, modular networks, and symbolic integration aims to improve it. Without compositional generalization, AI risks being powerful but narrow. How can generative AI be combined with simulation? Generative AI enhances simulations by generating realistic environments, data, and scenarios. For example, in aviation, AI simulates rare emergencies to train pilots. In finance, it simulates market shocks. By combining physics-based models with generative creativity, simulations become both realistic and diverse. This hybrid approach balances accuracy with exploration. The challenge is ensuring simulations don't drift too far from reality, which could mislead decision-making. What role does generative AI play in democratizing innovation? Generative AI lowers barriers to entry by giving individuals access to capabilities once reserved for experts. A small business can now generate ad campaigns, prototypes, or market analyses without large budgets. Students can explore science with AI tutors, and creators can produce professional quality content with minimal tools. The risk is uneven access. Those without digital infrastructure may be left behind. Democratization works only if access is inclusive. What is the role of human feedback loops in generative AI? Human feedback loops continuously refine models by aligning outputs with user expectations. RLHF is one example, but feedback loops extend to rating systems, user corrections, and post-deployment monitoring. This creates models that adapt to evolving cultural norms and contexts. Without feedback loops, AI risks stagnating or drifting away from human needs. Feedback is what keeps generative systems both useful and accountable. How does generative AI relate to artificial general intelligence, AGI? Generative AI is often seen as a stepping stone toward AGI, since it demonstrates broad capabilities across domains. However, today's models lack deep reasoning, true memory, or self-directed goals. A GI would require robust understanding, long-term planning, and adaptability. Generative AI shows glimpses of emergent intelligence, but remains narrow. It's an exciting frontier, but also highlights the gaps between today's tools and true general intelligence. How can generative AI improve collaboration in teams? Generative AI acts as a shared assistant in collaborative settings, drafting meeting notes, summarizing discussions, or proposing ideas. Teams use it for brainstorming, conflict mediation, or generating multiple perspectives on a problem. It reduces repetitive work and accelerates decision-making. The key is integration. Embedding AI in tools like Slack, Teams, or project management platforms. AI doesn't replace collaboration, but enhances it by freeing humans to focus on creativity and strategy. What is embodied generative AI? Embodied generative AI refers to AI integrated into physical systems, robots, drones, or IoT devices that generate actions as well as digital outputs. For example, a robot chef generating a new recipe and cooking it, or a drone adapting its path dynamically. Embodiment connects generative reasoning with the physical world. This is crucial for applications in logistics, manufacturing, and healthcare. The challenge is safety. AI-driven physical actions carry higher stakes than text generation. What are the long-term societal risks of generative AI? Long-term risks include erosion of trust in information, displacement of jobs, and concentration of power among those controlling large models. There's also risk of dependency societies relying too heavily on AI for decision-making. In extreme cases, generative systems could be weaponized for large-scale disinformation or cyber attacks. Addressing these risks requires proactive governance, ethical design, and public education. The technology's benefits are vast but unchecked. Its risks could reshape societies in unintended ways. What excites you most about the future of generative AI? What excites me most is the potential for human-AI collaboration at scale. Generative AI is moving from tools to teammates, supporting creativity, science, and education globally. Imagine researchers co-discovering cures with AI, or children worldwide accessing personalized tutors. At the same time, it's a chance to redefine work, letting humans focus on imagination while AI handles repetition. The future isn't man versus machine, it's man plus machine, building possibilities we couldn't achieve alone. And that's just the beginning. You've now seen 150 generative AI interview questions, but there's so much more to cover. If you found this helpful, make sure to hit that subscribe button and turn on notifications so you don't miss the next parts. Remember, preparation turns knowledge into confidence, and with the right preparation, your next interview could be the one that changes everything. Thank you for watching. Stay tuned.